This Introduction to Python series is part of the EPSCoR Track 2 DDMD workshop. This presentation is a discussion of text files. A file is a contiguous set of bytes used to store data. A byte is a unit of digital information, most commonly consists of 8 bits. The data within a file is organized in specific formats. File data can be anything as simple as text or as complicated as an image. In the end, file data is translated into bits, ones and zeros, for processing by the computer. Generally, a file is composed of 3 main parts. The header contains the metadata about the contents of the file. For example, it has information such as the file name, the size, the type, the date it was created. The data section consists of the file as written by the creator or the editor. For example, a Word file that was created by Microsoft Word. And lastly, the file ends with an end of file marker, which is a special character that indicates the end of the file. What the data within the file represents depends on the format specification used, which is typically represented by the file extension. For example, a file that has an extension of .gif most likely conforms to the graphics interchange format or image specification. And there are hundreds or thousands of file extensions out there. In this discussion, we're going to concentrate on the .txt or text files and .csv files, which are text files in comma-separated values format. When accessing a file on an operating system, a file path is required. The file path is a string that represents the location of the file, and it's broken up into 3 major parts. The folder path is the file folder location on the file system where subsequent folders are separated by a / for the Mac or a / for Windows. The file name is the actual name of the file, and the extension is the end of the file path pre-appended with a period used to indicate the file type. Let's consider the following file directory example. Let's say that you wanted within your Python program to access the file cat.jpg, which is in the pictures folder. You could use the relative path. So we could assume that you're in the website folder. So relative to the website folder, that file can be accessed using pictures / cat.jpg on a Windows machine. To locate that file from anywhere where you don't have to worry about where your current location is, you can use the absolute path. And on a Windows machine, the absolute path would be c:\mywork /website /pictures /cat.jpg. One problem often encountered when working with text files is the representation of new lines. A \r represents a carriage return, a \n a line feed. These are non-printable characters. They're characters that you don't see when you examine the text file in an editor, but often cause problems when you're processing these text files. These characters can be removed from your input by using the string method rstrip. So the rstrip method will strip the new line characters, the \r and the \n, from the text that was read in from the file. There are advantages to having your input come from a text file rather than inputted by the user at the keyboard. One advantage is that the data set can be much larger. Also, the data can be input more quickly and with less chance of error, and the data can be used repeatedly with the same program or with different programs. Text files can be created using text editors such as Notepad. And just like user input from the keyboard, all data read in from a text file is read in as a string. So for example, if you had a text file with a list of grades, each line of code representing a grade, when those lines of code are read in to your program, they're read in as a string and must be converted to an int or a float. When you want to work with a file, the first thing you need to do within your Python program is open it. Python provides a built-in function, open. The main required parameter for the open function is the path of the file. Optional parameters include the access mode. How do you want to open it? Are you opening it for reading? Are you opening it for writing? Are you opening it to append to it? And the open function returns a file object. Here we provide an example of calling the open function where we're opening a text file called results.txt, and because a path is not provided, we're expecting it to be in the current working directory, and we're adding the optional access mode parameter, R. This specifies that we're opening this file for reading. This open function returns a file object and we assign it to the variable FP. Notice that there's a variety of different access modes. So we can open a file for reading, we can open a file for appending, which is an A, open a file to write to it, which is W, and open a file X, which is creating the file. Here we present a more complete description of the variety of file access modes that are available to us in Python. Notice the R+ will open the file for reading and writing, and the handle, or where the file pointer is positioned at the beginning of the file, and an IO error is raised if the file doesn't exist. How does that differ from the A? From append, we open the file for writing. The file is created if it doesn't exist, and the handle is positioned at the end of the file. When you're working within Jupyter Notebook, sometimes it might be hard to identify what is your current working directory. Python provides a module called pathlib. So you can import pathlib, and then within pathlib you can call the path.absolute method, and it'll provide to you your current working directory. So for example, when I was working within my Python, I wanted to know what the current working directory was, and I found that it was c:/users/c/bo/EPSCORE Python workshop. If the file you're processing is not in the same working directory as your Python program, you'll want to specify a relative path. You can place an R before the file name to prevent the characters in the file name string to be treated as special characters. The R makes the string raw, and it tells the Python interpreter that the string is without any special characters. The R can be ignored if the file is in the same directory and the address does not include a relative path. So here's an example where I want to process a file that's in a subfolder of my current working directory. So if my current working directory is user/bow score Python workshop, I create a subfolder called input files, and within that subfolder I have a file called result.txt. So my relative path would be input files / result.txt. So we're going to consider an example where I have a text file that's comprised of a list of email addresses, and I've placed this text file in a subfolder of my current working directory called input files / emails.txt. I've written a segment of code that opens this file and then prints each line of the file. So first of all, note that Python provides a for loop functionality that allows us to process each line of an input file one at a time. So for address in email file takes each line of the input file and one by one assigns the line to the variable address. Then I print that address. So given the input file, notice the output file where I have a blank line between each address. This blank line is generated when our program is executed because our input file contains new line markers. So at the end of each line of our input file, there's a /r/n that we're not able to see. And this /r and this /n causes the Python interpreter to generate a new line between each line of this file. If this blank line is not desirable, we can use the rstrip method of a string to remove the /r/n. So in this segment of code, we open our email file. Then for each line in our email file, we take that line, which is address, and we strip off the right special characters and assign it to address, and then we print address. So notice in our output that there are no longer any blank lines. The built-in function closes the file and frees the memory space acquired by the file. It is used at the time when the file is no longer needed or if it is to be opened in a different file mode. Let's consider an example where we're going to use this email file and we're going to calculate the percentage of the email addresses that are from USD and the percentage of email addresses that are from SDSU. When we start working on our algorithm for this problem, we want to identify the input, the process, and the output. So what's our input? Well, our input are a set of email addresses. And where are they coming from? They're coming from a text file. Then what does our process entail? So for each email address, we're going to count it, we're going to get its domain, we're going to figure out if it's a USD email address, and if it is, we're going to add it to the USD total. If it's an SDSU domain, we're going to add it to the SDSU total, and then we're going to calculate the percentage. The output will be comprised of the percentage of the USD emails, the percentage of the SDSU emails, and the total number of emails processed. Just a reminder that an email address is generally comprised of three parts. The first part is the username, then we have the @ symbol, and then we have the domain. So the domain and username are separated by the @ symbol. Python provides a split method for a string that allows us to split a string by a given substring. So in this example, we have our email address and we want to split that email address into two parts, the username and the domain. So we can apply the split method to an email address and split it into two segments. So segment 0 will be the username and email segment 1 will be the domain. Let's continue working on our algorithm for processing email addresses. So given a text file of email addresses, we're going to calculate the percentage of those email addresses that are from USD and those email addresses that are from SDSU. So specifically, we'll begin by defining constant strings that represent the USD and SDSU domain. Then we'll initialize our USD, SDSU, and total address sums to 0. We'll open our email address file for reading. Recall that each line within that file represents one email address. So for each address in the email file, we're going to count it. Then we're going to split it using the @ sign. So the segments will be the first segment's the username and the second segment will be the domain. So if the domain equals the USD domain, we'll increment the USD count. And if the domain equals the SDSU domain, we'll increment the SDSU count. Once we've processed every address in the file, we'll calculate the USD percentage, calculate the SDSU percentage, and print the percentages and close the input file. Here's an example of what the solution to our address problem might look like in Python. Our initial statements define two string constants. One defines what a USD domain looks like. The second one defines what an SD state or South Dakota state domain would be. Next, we initialize all of our sums to 0. So we have a USD count, an SDSU count, and a total count, and they're all initialized to 0. Now we open our email file. So we open our file called emails.txt in the input file subdirectory, and we assign the file object to the variable email file. Now we read each line in the email file, and each line is assigned one by one to the variable address. So for each line we count it. So we increment total count to 1. Then we divide the address. We split it into username and domain. We set the domain equal to the email segment 1. Then we strip the new line characters from the domain. Now we can compare to see if that domain equals the USD domain. And if it does, we increment the USD count. Else, we check to see if it's an SDSU domain. And if it is, we increment the SDSU count. Once all of the lines in the email file have been processed, we can calculate the percentage and print the results. Guarding against division by 0 error, we use a try except segment. So we calculate the USD percentage, which is the USD count divided by the total count. We calculate the SDSU percentage, SDSU count divided by the total count, and then we print the results. And notice we're using the string format method. So the two arguments in the format method are the label or string USD percentage and then the actual value that we calculated, USD percent. And the format we're using is USD percentage label is mapped on to the curly brackets 0:30. So that means that label is going to be printed into 30 columns or 30 spaces. The second parameter, USD underscore percent, is mapped onto the second curly bracket format. And that one, we use the greater than sign to say we want the value right justified. And then we use the percent with 0 decimal places to show that we want it outputted as a percentage. The except is only executed if total count is equal to 0, and then we say there were no email address processed. That means our file was empty. And then this is the first time we've seen the finally part of a try-catch block or a try-except block. And the finally line is going to be executed no matter what, and that is to close our file. The string format method is new to us, so let's examine it more closely. The template or format string is a string which contains one or more format codes. The fields to be replaced are surrounded by curly brackets. The curly brackets and the code inside will be substituted with a formatted value from one of the arguments in the format method. Anything else which is not contained in curly brackets will be literally printed. If the brace character has to be printed, it has to be, you need to use an escape character. Let's look at a string format method example. So let's consider the first print statement in this segment of code where we have print and then we have the string I love curly brackets for curly brackets. So that's our string constant, and we're going to call the format method on that string function. So we call dot format, and then our arguments are geeks and geeks. The way the Python interpreter executes this print statement, it will map the arguments onto the curly brackets in our string constant. So the first argument within the format method, which is geeks, is mapped onto the first set of curly brackets, and the second geeks format within our format method is mapped onto the second set of curly brackets. The output generated by this print statement is I love geek for geeks. Notice that the first set of curly brackets was replaced by the first argument in the format method, and the second set of curly brackets was replaced by the second argument in the format method. The second print statement shows how you can use positional values within the curly brackets. So in this second print statement, we have the string constant, curly bracket 0, close curly bracket, and open curly bracket 1, close curly bracket. So in other words, we have within this string constant, a 0 surrounded by curly brackets and 1 surrounded by curly brackets. Then we take that string constant and we call the format method. We have two arguments within the format method, geeks and portal. So the way the Python interpreter will execute this print statement, it'll take the first argument within the format method and assign it to the curly brackets with position 0. It'll take the second argument within the format method and assign it to the curly bracket with the 1. If we examine the output from the execution of that print statement, we can see that the first parameter in the format method geeks has replaced the curly brackets that surround a 0, and the 1 surrounded by curly bracket has been replaced by Portal. The last print statement in this code segment is the same as the previous print statement, but we've reversed the 1 and the 0. So in our string constant, we have 1 surrounded by curly brackets and 0 surrounded by curly brackets. We call the format method on that string constant, and we use the same parameters, geeks and Portal. Examining the output from the execution of that print statement, we can see that the first argument in the format method, geeks, has replaced the 0 surrounded by curly brackets, and the second parameter, Portal, has replaced the 1 surrounded by curly brackets. So the position 0 is going to always be the first argument in the format method. Position 1 is the second position in the format method. Here are some additional options for formatting strings in Python. So you can see where you can use the less than and greater than sign to left align and right align your text. The caret would be for centering the text within a set amount of spaces. You can use the minus sign to make sure that if you have a negative number, the minus sign shows up for negative values only. Some additional formatting options allows you to specify how you want numeric values to be displayed. For example, you'd use a D for a decimal format, a lowercase e for scientific format, a F for fixed floating point. Some additional formatting options include being able to display a numeric value in octal format or hexadecimal format, and we have the option to be able to output a numeric value as a percentage. We'll revisit our print statement that allows us to display the percentage of email addresses that belong to the USD domain. So we had our print statement, the first set of curly brackets within our string constant, 0:30. We map that onto the first argument in our format method, which is the string USD percentage. So we're going to use 30 spaces to print that string constant. The second set of curly brackets, the 1 represents the second parameter in our format method, which is USD_%, which is a floating point value. We want it to be right justified, and we want it to be displayed as a percent with 0 decimal places. These formatting options gives us great flexibility in how we want our output to be formatted. Notice that in our output, in our example for our email addresses, we're able to format all of our numeric values to be lined up in a column.